Now I wanted to get into the final set of mechanics that we should consider, which is large language models, which I know we're in design and we're heavily visually based. We're going to use text to generate images as well, or we're going to use text to brainstorm or refine our concepts. So it's really important that we also understand how large language models work. So here's the gist. It's essentially a chunk of the internet. A lot of it is trained on just the internet. I mean, there's a ton of stuff on the internet. So imagine this web of the internet being processed in data centers. So a GPU, a graphics processing unit, like our laptops have CPUs. A GPU is a computer chip managed by many math tasks at once. GPUs are much more efficient than CPUs. And now we have a bit of a race towards GPUs and having more power to store more data. Nonetheless, it can be very expensive. So in this example, for a large language model, they process quite a bit of the internet, and it took 6,000 GPUs over 12 days, which cost $2 million, which is why you'll find a lot of AI applications just on the backs of existing large language models. So like OpenAI powers a ton of other AI apps. A good one even is Perplexity for research. Is great, but it's just powered by OpenAI because it's incredibly expensive to create a large language model. Ways around it, like renting servers. Okay, that's a whole other conversation. Anyways, it's then compressed. The data is compressed a lot like a zip file. So it can compress so much data in this example, we went from 10 terabytes to 140 gigabyte file. So it can compress a lot of data. And how does it work? So there's something called tokens you might already be familiar with. Tokens are just like assigned numbers, if I was going to put it simply, to each word or symbol. Let's say each word. So here we have, my favorite color is red. Well, what the AI is actually seeing is just these numbers, these string of numbers. So this is kind of fun to see because with these different AI apps, you are limited. This link doesn't work. You are limited to a certain number of tokens, depending on your membership or subscription. So it can be helpful, especially if you start using AI at large scale. You'll want to know how many tokens you're using so you don't run out and so you can budget for it. So especially if you use like for automated tasks and things like that. So hi, hello, how? So you can see just that is 8 tokens, 28 characters. Each one of these is a string of numbers. If I put doing, yes, doing is 3815, 15. The question mark is 30. So again, kind of like what I was saying about AI, it doesn't experience the conversation the way you are. Like we're looking at these images. It's not seeing what you're seeing. It's just seeing these numbers. So it works like a calculator and be kind of that simple. And furthermore, does it generate text? So actually, it's just predicting the next word based off of probability. So a lot like texting on your phone, how it can just predict the next word. That is pretty much how it works. But it's doing every time it creates a new word or a new token. It will go through the entire process again of finding the next most probable word. So if I wrote once upon, and then it would be like, okay, it's most likely they're going to say A, and then it goes to the machine again. Okay, once upon A, and it's going to predict time. It's going to go again. Once upon a time, there. And then then it probably gets really creative and starts a whole new story. But how many times in books that start with once upon a time, it is embedded in the model that these words would probably be strung, or these numbers, these tokens would be strung together. And it kind of works kind of how I was saying that reward system or based off of probability, it's going to go for A. It's more probable, 0.5 chance being what you want than if they went with the or for, and so on. So again, it's just grabbing the most probable word. For example, I wrote once upon a time, and then it gets creative. So it's always probably more than likely going to be once upon a time. Yes. Okay.